Okay, we're going to take a look at example A from your book. We have the circumference of a circle is equal to 2 pi r, where r is the radius of the circle. The length of an arc subtended by a central angle of n degrees is equal to this equation, or this formula, of n divided by 360 times that circumference of 2 pi r. So what we have is our radius right here. We have the subtended arc, which is right here. And to find the length of this arc, in other words, we're going to go from this endpoint to this endpoint here, we can use our formula of n divided by 360. So essentially what you're doing, that angle degree, this angle degree, or this amount right here, is part of the entire circle, which is 360, times that circumference of 2 pi r. So times your circumference of 2 pi r. Let's look at our example from the book. We have a pet gerbil runs the length of an arc. So we're talking about the subtended arc on a circular wheel with a radius of 12.5 centimeters, which subtends a central angle of 40 degrees. We're going to figure out what length the gerbil traveled. So my n, I'm going to replace with my 40 degrees, my central angle. I'm just going to fill it in right there at 40 over 360 times my 2 pi r radius, which right here is the 12.5. So I'm just going to put it in right there. And I'm going to multiply all of that out. And I'm going to, kind of like what we did on the warm-up, I'm going to do a little bit of reducing before I do that. So 40 over 360, let's reduce that down. That can reduce to 1/9. And I'm going to bring that down here, and I'm going to multiply that times 2 times the 12.5 of 25 pi. It's a little bit better. And then when I multiply all of that out, I get approximately 8.7, and we were in centimeters, 8.7 centimeters. Okay? All right, the next thing we're going to do, I told you we were going to look at taking our degrees and converting them over to radian measure, because that is what we do in calculus. So I just want to kind of show you where the radian measure comes from. The radian measure of angle AOB down here is the number of radius units in the length of the arc AB. So here's our arc AB. So that's what a radian measure is. We're going to call the radian measure theta. Theta is equal to the arc length, in this case it gave S, divided by the radius. So if we used that, whoops, back up. So if we use that and we take a look at a couple of circles here, if I use this, I'm going to have, for my first theta, I'm going to have 5 over 2 if I use my formula here. And that would be my theta. And then if I look at the second one, a little different here, they tell me that that arc length equals the radius. So if my arc length equals my radius, my r would be divided by r, or simply 1. So 1 radian will equal the measure of a central angle, in this case theta right here, whose arc has a length of r, which is this right here. Now, if I want to do the converting, I just want to kind of show you how we get to the formula. We know that if we go around a circle, we know that that 1 revolution equals 360. Now, if I look at the outside of the circle, or the circumference, I know that my circumference is 2 pi r. We just used that a second ago. So if I take that as my arc length, since I'm going around the entire circle, I'm going to put that in and find theta. So if I have 360 equals 2 pi r over r, and I want to simplify that down, well, my r's will cancel, so I will have 360 equal to 2 pi, and then if I divide out my 2, I find, in fact, that pi has a value of 180. So it is this value of 180 equaling pi that we use to come over here and work our formulas. So our first formula, if we want to convert degrees to radians, I will take whatever my degree is, multiply by pi over 180. And if I want to go from radians to degrees, I'm just going to kind of reverse that. I'm going to take my radian, and then I'm going to multiply that. Since we're kind of just reversing what we did, or inversing, I'm just going to take the reciprocal of 180 over pi. Why can we multiply by the pi over 180 and vice versa? Well, what did we just discover back over here? They actually equal each other, right? So essentially, this is a 1. And we are not changing the value of the degree or radian. We're just rewriting it. We are just rewriting it in that special form of, using that special form of 1 so we can have the conversion that we need. So let's try these down here. So I have negative 225 degrees. I'm going to change that to radians. So I'm going to put that in. Negative 225, and I'm going to multiply that by the pi over 180. So I'm going to do some reducing with the 180 and the negative 225. So I can reduce the 225 and the 180 by 45. And that would give me a 4 down here and a negative 5 in my numerator. And I multiply that out, I'm going to have negative 5 pi over 4. And now I've converted to radians. Let's take the 50 degrees, multiply that by the pi over 180. We can do some reducing here. We can reduce those zeros down, and I would be left with 5 pi over 18. Now let's reverse it. So now I'm going to convert my radians back to degrees. So I'm going to use my second formula here. I'm going to take my radian of negative pi over 3, and I'm going to multiply that by 180 over pi. So you should see instantly that, in fact, those pi's will cancel each other out. So let's do that. And that 180 and the 3 can reduce by 3. So I would have a 1 here and a 60. So essentially I'm going to go back and I'm going to have a negative 60 and put your degree in. And our last one, so we're going to take that 3/4 pi, multiply that by the 180 over pi. Again, my pi's are going to cancel each other out. So I have the 3 times the 180 over the 4. I can reduce the 4 and the 180. So 4 would give me 1, and 180 would give me 45. And so 3 times 45 gives me a degree of 135. Don't forget your degree. All right. We will check these in class, and if you have any questions, email, or you can catch me on Edmodo.